Okay children, in the previous classes we studied about force. Now let us study about a different concept, that is pressure. You might have observed during the strong winds, cyclone, thunderstorms. Why this occur? This occur because there is a air pressure variations. Because of the air pressure variations. So there is some relation between the pressure and force. Now let us study what is the relation between the pressure and force. Pressure is nothing but force acting per unit area. You might have seen a nail. The tip of the nail is pointed. Okay, when you try to pierce this nail into the wall, how do you pierce it? Either through the broad end or through the tip. We pierce the nail into the wall through its tip. It is because there the area is less. The formula for pressure is force by area. So when the denominator, when the area increases, what happens to the pressure? When area increases, pressure decreases. When area decreases, pressure increases. I will give you some examples. You might have used the knives. You might have thought, why the surface of the knife is sharp? Why the tip of the knife is sharp? Why it is sharp? Because their area is less. So when area is less, the pressure exerted will be more. Similar is the case with the nail. The tip of the nail is pointed, area is less, so the pressure applied will be more. When you take the case of, that is, buildings. Why do buildings have broad foundations? It is because when they are having broad foundations, area is more, so the pressure will be less. You might have seen lorries, bulldozers, buses. The tires of these vehicles are broader. Why the tires are broader? Their area is more. When the area is more, we know that pressure P is equal to force by area. When area is more, what happens to the pressure? The pressure decreases. In order to avoid extra pressure, what we do is area. We increase the area. When the area is increased, the pressure decreases. In case of pressure, the force will always be acting in the perpendicular direction. It will be acting in the perpendicular direction. The formula for pressure is P is equal to F by A. Unit of force is Newton and the unit of area is meter square. The unit of pressure is Pascal. 1 Newton per meter square is the unit of pressure and it is also Pascal. Another example I want to give you is, why do we use broad straps for the bags? You all carry school bags, isn't it? Have you ever observed why the straps are broad? Here also we are trying to reduce the pressure. So when we are increasing the area, the pressure decreases. I hope you have understood all these examples. Example of a nail. The tip of the nail is pointed, area is less, pressure will be more. Knife is having sharp edges, area is less, pressure will be more. Tires of the buses are broad, area is more, pressure will be less. Similarly, the straps of the bags are broad, area is more, pressure will be less. Like how solids exert pressure, liquids also exert pressure. Liquids don't have a particular shape. They take the shape of the container in which it is placed, isn't it? Liquids exert pressure along the side of the container and the bottom of the container. With the help of 3 activities, I am going to explain what is this liquid pressure. The first activity, we are taking 2 glass tubes. It is given in your textbook. In these 2 glass tubes, at the bottom you are tying a rubber balloon. You are filling this glass tube with water. Okay, so when we are filling this glass tube with water, what happens to the balloon? The bulge in the balloon start increasing. When the level of water increases in the glass tube, what happens? The bulge also increases. What do you understand from that? That is, liquid exert pressure in the bottom of the container. Liquid is exerting pressure in the bottom of the container. Another one activity that is given in your textbook is, you are taking a bottle, then you are taking a glass tube, you are heating the end of the glass tube, you are inserting it into the bottle and then you are just sealing it with molten wax. Then you are filling this bottle with water. When the water is filled in the bottle, and to that glass tube, one end of the glass tube, you are fixing a rubber balloon. I hope you have understood this activity. You are taking a bottle, you are heating the end of a glass tube, you are inserting it into the bottle and you are sealing it with a molten wax. In the other end of the glass tube, you are fixing a rubber balloon. So when we are raising the water column in the bottle, what happens is the bulge in the balloon also increases. What do you understand from that? the liquids exert pressure on the walls and the side of the containers. So only the bulge increases. So first thing, in the first activity, what did we learn? Liquid exert pressure in the bottom of the container. In the second activity, what did we learn? Liquid exert pressure along the side and the walls of the container. Okay. In the previous two activities, what did you understand? Liquid exert pressure in the bottom of the container and liquid also exert pressure in the side and the walls of the container. You know, this is a bottle. Suppose you take equal distances from the bottom. Make holes at equal distances from the bottom. Take a bottle, make holes at equal distances from the bottom. You can measure it with a scale, and then first you have to close it with a tape. After that you fill it with water. Then if you remove the tape, you will find out that the water will be falling at the equal distances. So what do you understand from this experiment? First we are taking a bottle, then we are making holes at equal distances from the bottom, and then we are first covering it with a tape, filling this bottle with water. When we are removing the tape, the water from these holes are at equal distances from the bottom of the bottle. Okay, so this water will be falling at equal distances, and this shows liquid exerts equal pressure at equal depth. And one more thing, children, liquid pressure increases with depth. As how liquids exert pressure, gases also exert pressure. For example, in the case of balloon, when we inflate a balloon, what happens? The gas is also exerting pressure on the walls of the balloon. The gas is exerting pressure on the walls of the balloon. At the same time, in case of a bicycle tube, when the air, that is when there is any hole in the bicycle tube, what will happen? It becomes puncture. And when we fill it with air, what happens? It expands. Here also, gas is exerting pressure on the walls of the container. Liquid and gases don't have a particular shape, so they take the shape of the containers in which they are placed. Okay, now I hope you have understood about liquid pressure. I told you that gases also exert pressure. Now what is this atmosphere? We know what is atmosphere. The layer of air surrounding us is called atmosphere, and this atmosphere extends several kilometers above the earth's surface, and this atmosphere also exerts a pressure on us, and that pressure is called the atmospheric pressure. We have studied pressure is equal to force by area. We studied pressure is equal to force by area. Suppose you consider a cylindrical column, and if it is placed on a unit area, we know that pressure is equal to force by area. Suppose you consider a unit area and you are keeping a cylindrical column on it. You are keeping a cylindrical column in it. The air is filled inside the cylindrical column. The force of gravity acting on this air will give you the measure of the atmospheric pressure. Suppose you consider a unit area and you are keeping a cylindrical column in it that is filled with air. Suppose that is the force of gravity acting on this air will give you the force of gravity acting on this air will give you the measure of the atmospheric pressure. You might all be thinking, you might have seen a rubber sucker. You might have seen a rubber sucker like thing that you fix on the wall. Why it is fixed to the wall? It is fixed to the wall because of the atmospheric pressure. Rubber sucker, then you hang things on it and all. If you want to pull the rubber sucker, you have to apply a force greater than atmospheric pressure. The rubber sucker is fixed to the wall because of this atmospheric pressure, and there should be a layer of air between the sucker and the wall. Only then you can pull it up. That much strong is the atmospheric pressure. Some other examples, like when you are taking the ink with the ink filler, first we are pressing the filler, we are letting out the air, and then the atmospheric pressure is pushing this liquid into the filler. The same thing is happening when you are drinking the juice with the straw. There also, that is when you suck out the air, the atmospheric pressure acting in the liquid will push the liquid into the straw. I hope you have understood all these things. And then even if such strong atmospheric pressure is acting on us, why we are not getting crushed under it? You might be all thinking, why we are not crushed under this atmospheric pressure? We are not crushed under the atmospheric pressure because inside our body also we are having equal pressure. Inside our body, the fluids are also exerting equal pressure. That is what blood pressure is called. So inside our body, the pressure is balancing. This pressure is balancing the atmospheric pressure. Although the magnitude of atmospheric pressure is very much high, we are not crushed under atmospheric pressure. It is because our body pressure is balancing the atmospheric pressure. That is the reason why we are not crushed under atmospheric pressure. So what and all things we learned today? We learned about what is pressure. Pressure is force acting per unit area. The unit of pressure is Pascal. And then we also learned about atmospheric pressure, the pressure exerted by atmosphere, and we also studied about liquid pressure. Okay, bye children, meet you in the next class.